Okay, so we're setting the membrane and the stacked rings for our DSS. We just trimmed the specimen using the GNR trimming jig, and we use highly polished stainless steel rings. And what we do is we put it in a bath of 5 CS silicone oil, and then we take it out of the bath and just let the excess oil drip away. And then we use that silicone oil just to lubricate the inside of the membrane, and we'll actually do the outside also after we've placed it. So just put the membrane down, make sure we're below the bottom mark where we're going to put the O-ring that holds up our rings, then release the vacuum. So now I'll pull the membrane out of the membrane stretcher, and so I'm going to then first I'm going to take, actually we need to place the O-ring here. So I went a little lower than I would like on the bottom here. I prefer to have a bit more on top in case we have to stretch the membrane to get the rings to pass. But we will see if this works. It should. So all I'm doing now is I'm just any obvious air I see, I'm just pushing it up to the top to try and bleed it out. A little bit of silicone oil around that. Then we have our O-ring. The O-ring is not necessarily for sealing. The O-ring provides basal support for the stacked rings. So I'll take the O-ring down on here, snap the O-ring, make sure it's seated in the groove. So that's good. Now we take our stacked rings, which are lubricated with the silicone oil. We place that in our jig that is going to hold the top cap up so that I'm not transmitting any force to the specimen while I'm placing the rings. So I'm going to lock this in place on the tie rods. That's locked, and then this locks the top cap, so that remains stationary. And now I take the first ring, and you really want this overall to be a tight fit. So you need to place the rings one at a time, and you also need to check that your membranes are not too thick. Sometimes the membranes come in a little bit too thick, and so you're going to need to pull up on the membrane for me there. This one is not going down as easily. Yeah, there we go. So Martez is just stretching the membrane a little bit. Okay, you can stop for a sec. And we got the first one down. And second one, and so on and so forth. So sometimes this can be a two-person job, other times, so I don't think you need to pull anymore. I think it's going fine. You want this to be nice and tight so that you don't get, no, I need you again to pull up on the membrane. It's just around the top cap. I have a feeling this top part of the membrane is slightly thicker than the other part. Depending on the quality control of when the membranes are made, you may have some differential thickness, and we've had some membranes where we couldn't even use them because they were too thick. Couldn't get the rings down. So we're doing a Shansef test on this one. So the strains per se are not critical in terms of the compression curve, but we like to get as close to what would be the equivalent of a 1D compression curve as possible. So we really like this to be a nice tight fit between the soil perimeter, the membrane, and the stacked rings. Of course, you want to make sure you have enough rings to go all the way up through and have the top cap below the top set of rings. Yep, that's good. And then finally, we have 3 screws that clamp the rings together, and we leave those screws tight during consolidation, clamped, and then just before shear, we will remove them. So I'm placing one here, and again, these are just going to be finger tight. Okay, you can stop. So we now have the specimen in our GNR DSS device, and we've measured the height of the specimen, or we've measured what it is from the top cap to the base, and we know what it is without the specimen, so we have our height. And now we're just going to connect the drainage lines. There's no back pressure saturation in the DSS device. When we do shear, we do constant volume shear, So the water that we provide to the specimen is not to saturate per se, it's just to keep it moist. And what we do is we have our drainage lines, we connect one to the top, one to the bottom, and this is actually going to be the back side. And so I rotate around, and then on our front side, we have a drainage line that we connect to the bottom, and you can use a burette that we've used for many years, or Morteza has this water system that he uses. So we have a line that comes out of here that's connected to the bottom, and then when we are ready to flush the stones, which were set up as moist stones, moist meaning we had them in an ultrasonic bath, left them there, we took them out, we damped them, the free water away from it with paper towel. When we're ready to add water, which we usually add once we've reached what we think is the sampling effective stress, so we're not going to get any swell, then we will flow water from the reservoir here down into the bottom stone, across the stone, up to the top stone, and then out the back side, and then it's going to be connected to the final line here, which is free draining, and that'll just free drain to a burette, or sorry, a beaker. And we try to keep the elevation of the water here about the same as the height of the specimen. You don't want too high a gradient across the specimen. But again, it's just to keep everything moist there. And now we're ready to put it in the GNR jig and start consolidation.